everyone, I am Dr. Jagadha, Associate Professor in the Department of Mathematics. Today we will discuss about Gauss Divergence Theorem. In detail, we will talk about, through this video lecture, we will discuss in detail about definition of Gauss Divergence Theorem, problems based on Gauss Divergence Theorem. The definition of Gauss Divergence Theorem is, let capital S be a closed surface enclosing a volume V. That is, the closed surface, here the closed it is there, that is, the starting point and the terminating point coincides, and volume, so length, breadth, height, or length, breadth, depth, it will be there for the geometrical figure. That is, the capital V, the volume, which represents the geometrical figure which is in three-dimensional, whereas it's a surface it is there, that is capital S represents it is two-dimensional. Now, if the vector capital F is a continuously differentiable vector point function, just it is a vector function. That is, vector, it represents, it has not only magnitude, it has direction. To the function at the particular point is vector point function. This vector point function, that is our capital F bar, that is, that bar denotes it is a vector function which is differentiable at the particular point. That is, the particular point which is differentiable in the sense, that is a definition of differentiable, that is, limit x tends to a plus, that is, x is greater than a, that is, the point x at a point a, or we can tell x is greater than a, that is, a plus represents f of x minus f of a divided by x minus a, that is, we will substitute in the what is the given function at this point a, one result we will be getting. Same treatment, limit x tends to a minus, that is, x is less than a, f of x minus f of a divided by x minus a. These two values after substitutions, if you are getting, that particular function is differentiable. That is, our vector point function which is differentiable, and which is not only differentiable, it is continuous also. That is, it is continuous in the sense, limit x tends to a, suppose the function is f of x, x is replaced by a equal to f of a, that is continuous. Now, so our vector point function which is continuous and differentiable. So now the Gauss divergence theorem is nothing but the V represents volume, S represents surface. That is, volume integral, divergence of F, volume integral, which is equal to surface integral, that is, F dot n. N is nothing but normal vector, that is the normal vector which is perpendicular to our surface. That is, this is our vector function which is given in the question. This is ds, that is the which we are doing, the surface, that directions, in which plane it is there. Totally x, y, z, three are there. The particular surface, either it is in xy plane or yz plane or zx plane, that we have to see it, and we have to project that one. So Gauss divergence theorem, it's nothing but the divergence of your particular vector point function volume integral, which is equal to the vector dot product of the vector function into the normal vector over the surface. Surface, it is in, this is in 2-dimensional, this is in 3-dimensional. Both are equal. That's what our Gauss Divergence Theorem, which is defined. Now, here this n vector, which is in the right hand side, that is this n vector which is dominating in our surface integral. In the surface integral, that n vector is playing the role outward drawn normal vector at any point of S. That is surface, it is there. The surface, so many infinite number of points are there. So those points, any point, this normal vector which is perpendicular to the surface. Now we will take a problem, verify Gauss Divergence Theorem for, this is our vector point function which is given. That is 2x square yi minus y square j plus 4x z square k taken off the region of first octant of the cylinder y square plus z square equal to 9 and x equal to 2. This solution we have to, before that, what is given in the question? This is our function, the vector function. There I, j, k mutually perpendicular vectors. Cylinder, our geometrical figure is cylinder, that is y square plus z square equal to 9, and which lies 3-dimension. It lies our geometrical figure, which volume we are going to find, that is surface integral, which is equal to divergence of the particular function volume integral is equal, that we are going to verify. So our area, our volume, what we are going to calculate, that is which lies in the geometrical figure in the 3-dimensional first octant, it plays a role. Fine. Next, a curve which is given. The curve, so totally our problem which is in 3-dimensional x, y, z. In that, y square plus z square equal to 9. That is our surface which is in a curved one. And from origin to x dimension, the unit is 2 unit, the distance it is there from the origin. That's what, these are the points, informations which is given in the question. With that, we have to first draw the geometrical figure. Before that, our vector point function, that is our capital F, is nothing but f1i plus f2j plus f3k. Then our divergent f, we can see it. That is del dot f, grade dot f, gradient. This gradient is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z dot this f vector. Dot product, only I dot I, the value is 1, j dot j, the value is 1, and k dot k, the value is 1. This is also, we have to keep it in our mind. Now we can see it, this divergent f, div f. Mathematically, gradient dot f. The gradient for this is written, that is I by dou x plus j dou by dou y plus k dou by dou z, and this dot product is as it is. Next, here we are noticing f1i plus f2j plus f3k. This divergent F, here it's only one is there. So grade dot F, we know it I dot I only exists. Here we can see it. I dot I exist and J dot J exist. Here K dot K exist. So div dot F. So dou F1 by dou X plus dou F2 by dou Y plus dou F3 by dou Z. Fine. Next, this is our function, that is 2x square yi minus y square j plus 4xz square k. This, what is from which, what is F1, what is F2, what is F3? That is, this is playing the role F1, this F2, and here F3. So F1, it's replaced by 2x square y. Our F2, which is replaced by our minus y square. F3, which is replaced by 4x z square. Now, dou represents the differentiation. Partially we have to do it because dou is the symbol of partial differentiation. Now dou by dou x, that is this term 2x square y, with respect to x we have to do it. So with respect to x we have to do, then y is treated as constant. So only this x square we are doing, that is 2x. Put together we got it 4xy. Next we are moving to the next one, that is minus y square is there. So here we have to concern, we have to give importance, we have to do the differentiation partially with respect to y. So y square, it's nothing but 2y, that is minus 2y. Next, the last one is with respect to z we have to do it, that is z square, that is 2z. So put together we got it 8xz. We can see it. So first one 4xy, that is partially with respect to x we did, that is F1 partially we did with respect to x. We obtained the result 4xy. F2, that is our minus y square, we did partially with respect to y. We obtained minus 2y. F3, that is 4xz square, we did partially with respect to z, we obtained 8xz. So now, which is some bounded region is there, that already we have seen in the question, that is 1, it is given curve y square plus z square equal to 9 and x equal to 2. So we have seen here, that is it is YZ plane, it is a curve. Actually we know it, this equation is in general equation of the circle. So now our shape, the surface, it is in curve shape in YZ plane, surface 2-dimensional. So YZ plane, which is equal to 9, and from the origin x, it moved the distance, that is x equal to 2. This is the information which is given in the question. So with this, totally, that is the Gauss Divergence Theorem, that is surface integral which is equal to divergence of the volume integral, 3-dimensional. So we have taken the coordinates, the axis, first we have drawn it, and while naming part we have to do it. This is the center, yeah, we represented, we named it as O. Fine. Compulsory surface, the cylinder surface, it should be in YZ plane. That from the question which is given, that we have to give importance according to that. So Z is there, this and Y. Because we needed the surface of the cylinder. It is here the condition which is given. That is the reason x-axis we put it towards up. Now there is a point A in y-axis and there is a point B in z-axis and there is a point E in x-axis. So just we are drawing the lines. We can see it. The cylinder, we have framed it. Now, so this point we are naming as C and here the point is D. Now we want it. This reason we understood this is the AOB. This is the surface of the cylinder. This is the down part. Exactly, this is the upper side. We are in three-dimensional. So the surface is there. This is the height. That is cylinder height. That is this size is given 2. Here it is mentioned. We want it now. Here. That is, this is surface. That is YZ plane it is there. We want it when we are doing the integration, when we are going to find the volume integral. For that, regarding this surface, the limits we want it. The interior one regarding curve, what is that we will put it. So, triple integral, the interior one we will define for Z. So, Z from where to where? This is the center, the origin 0, 0, 0. Now, 0 to starting and it is touching the curve. Our curve is nothing but this one. That is which is in YZ plane. So, y square plus z square equal to 9. From which we can extract what is z. So, z square equal to 9 minus y square. So, z equal to square root of 9 minus y square. So, the limit, the interior one, strictly we will allocate it for always the interior one. Regarding the curves are there, we will. The outermost one, constant or real numbers related one, if you select, then we will be very comfortable in solving this type of problems. So now the curve one starting to touching the curve, so 0 to square root of 9 minus y square. So z is over. The next, the middle integration, the limit y. Our y-axis from O to y, here it is there. This is the picture which is given. So, y square plus z square equal to 9. If we cancel z equal to 0, then y square equal to 9, y equal to 3. So, plus or minus 3 will come. That's what in the question which is given, first octet. Only positive only we are going to take. Okay, fine. So, from O to this A, the distance actually it is a 3 unit. And here the unit is, which is given actually, it's a point 2 units which is given. Okay, fine. Next, x, the final one, the outermost one from 0 to 2. That is given in the question. That is at x-axis, there is a point 2, it is there. So O2E, it moves towards, there is x-axis a point 2, that is 0, 2, O2. Then the value from 0 to 2. So the limits we have taken very clearly. 0 to square root of 9 minus y square. It is allocated for z, y equal to 0 to 3 for y, x equal to 0 to 2. Now, this is the figure. So what we have discussed in the previous slide. The same figure. Now, volume integral V, that is grade dot F, triple integral. The interior one from Z to, that is from Z, Z is taking the value from 0 to square root of 9 minus y square. And y is taking the value from 0 to 3 and x is taking the value from 0 to 2. This is what we have got it. Our grade dot F, already we derived it substituting in the formula divergent F. We got it 4xy minus 2y plus 8xz. This is dv. D is a dy dx. Compulsory we have to write in this format only. That is, we can't write this is a dx dy dz or dy dz wrong, because the interior one which is defined for z. So we have to do integration with respect to z only for the interior one. The middle one compulsory with respect to y. The last outermost one with respect to x. Now we will focus our integration for the interior one. So now we can see it here in this 2, which is common, it is there, we have taken out. And before that, here we can see it. 4xy is there. We have to do our integration with respect to z, we have to do it. 4xy completely they are treated as constant. It is written as it is. Whereas dz for the first term, it is z. Just I am putting a tick. And minus 2y, we didn't touch it all. As it is, we copy it. Into dz. Dz integral is z. And here 8x also, we didn't touch it all. They are treated as constant, even though they are other variables. We are focusing on integration with respect to z. But 8x, other variable, they are treated as constant because they are under the operation multiplication. Next, z, the integral is, that is, x power n dx, it is there. So, x power, simple integral, x power n plus 1 by n plus 1. So, now our z power is 1, 1 plus 1 by 1 plus 1. So, only in this particular place only we applied the integral formula. So, interior integration we completed and z is taking the value from 0 to square root of 9 minus y square dy dx. 1, 2, 3, 4. We didn't touch it all. Just seeing the before step, we wrote it. only we focused on with respect to z integration. So after doing the integration, now the limit values we substituted. That is, this cutting we are getting 4. In the place of z we have to substitute it. Here is there, and this place. So where I put the 3 places the tick, there we are going to substitute our upper limit square root of 9 minus y square. Here the first term we are seeing minus 2y is common. So 1 minus 2x minus 2y we have taken. And here z is there. That we have put it, substituted our upper limit square root of 9 minus y square. Here 4x, here z square is there. 4x, z square is there. Z is taking the value square root of 9 minus y square, the whole square. This getting cancelled. Only 9 minus y square. And lower one is 0. If we substitute in the place of z, anyway, we are getting the result to be 0. Just we didn't write, we neglected it. So the interior integration with respect to z, integration is over. Substituting the limits also over. Now, we are going to focus now the middle integration. So the middle integration is from 0 to 3. So from 0 to 3, how to do this integration? Very difficult one, but there is a formula to help us. That is, with respect to y, we are going to focus now. F of r, I am going to take what I am circling, this 9 minus y square as f of r. So f dash of r is minus 2y f dash of r. Here we have minus 2y, it's playing the role f dash of r, and 9 minus y square, which plays the role f of r. The power is 1 by 2. That is, it plays the role n. So minus 2y of 9 minus y square, the whole power 1 by 2. Fine. So exactly it fits our formula. That is, f of r power n plus 1 by n plus 1. Our n is 1 by 2. So 1 by 2 plus 1, 3 by 2 divided by 3 by 2. That's what simply using this formula we integrated up to here. That is, 2 terms are there. First term we integrated. So we can see it. This written as it is. This now we explained. That is, this is playing the role, our f of r. F of r power n is 1 by 2. So 1 by 2 plus 1, 3 by 2 divided by 3 by 2. And this 4x also written as it is. Here the simple integration, 9 into dy. dy integral is y. So 9y. This minus sign as it is. Y square, the integral is y cube by 3. That is a simple integral formula from 0 to 3. Now, upper limit in the place of y, we have to substitute. So, where y it is there? Here it is there. That is 3 square, 9 minus 9. it has totally become 0. This part is 0, 0 into anything, 0. This plus 4x as it is. Here 9 into 3, 27, minus 27 by 3, 9. So the upper limit substitution is completed. Now this is limit formula. Now we will move to our lower limit concentration. So the lower limit is 0, where in the place of y we have to substitute. Here this 3 by 2 is there, just we will bring it up, then it will become reciprocal. So 2 by 3. This we have written as it is because we did the integration with respect to y. So in the place of y we are going to substitute. So here we are substituting 0. So 9 power 3 by 2. We can write it 9 power 1 by 2 power 3. Square root of 9, it's nothing but 3. 3 cube is 27. So complete the middle integration. Here is there. We have taken the help, this formula. We substituted upper limit. And here is their upper limit. Limit formula, lower limit. Now, so the 4x of 27 minus 9 minus 2 by 3 of 1 minus 2x of 27 dx. So the outermost integration is 0 to 2. Here 27 minus 9, which is nothing but 18. So 18 into 4x, 72x. Here this cutting, it's 9. 9 2s are 18. 1 minus 2x, which is written as it is. Now 0 to 2, 72x minus 18. We have taken minus inside, plus 36x. So now this both 72x plus 36x put together 108x minus 18 dx. Now we will do the integration, the outermost one in the direction of x. So with respect to x from the limit range 0 to 2. Here x power 1 is there. The integral formula x power 1 plus 1 by 1 plus 1, that is x square by 2 minus 18x. That is dx integral is x from 0 to 2. So here 216, that is in the place of here x we substituted the upper one is 2, 4 by 2, 2 into 108, 216 minus as it is 18 2s are 36. So 216 minus 36, which is equal to 180. That is volume integral divergent f dv. The left side of we got the result of volume integral 180. So Gauss Divergence Theorem 50% we completed. Now we will move to the right side, that is regarding surface integral. So in this part we completed, the result we got it 180. Now we have to focus our surface integral f dot n ds, that is our cylinder. It has 5 faces. Now we can see it, that is S1, S2, S3, S4, S5. Sorry, actually only up to S5. So we can see here very clearly, phase 1 we are taking. The phase 1, that is OAB. This we are naming as S1. And here if you're noticing, it is YZ plane. That is very, very important. Now you can see it, the complete figure, the lines are in black color, which we are projecting, which we are focusing, that it is in different color which is given. There is a pink color which is there. That is a S1. OAB, this is our surface. S1, that it is named it here. And YZ plane this is. That's what here, the surface to calculate the area dy dz, it is written here. And x equal to 0. We can see it here from the origin, the x dimension here. This opposite side, that is north, the value x value is 0. But up one, if you are taking x value is 2, that's what which is given in the question. Fine. Now, our thing it is there, we want, the formula is, surface formula is f dot n ds. Our n is normal vector. The normal vector means which is perpendicular to our surface. So, which is perpendicular to our surface? Now, we are in this figure. So, S1. From here, O to E, if it is there x dimension, this is a normal perpendicular to our surface, but when we are concentrating, it is opposite side of ECD. So when it is opposite side, then the unit, the normal vector is minus I. But if you are taking CED, the normal vector is I. But the opposite side of CED we are taking. So here our normal vector is minus I. So that's what here minus I it is written. Now our area, surface area of our this S1 is dy dz. Y range from already the limits we calculated, that is y purpose, that is 0 to 3 it moves. That's what y lies between 0 to 3. And what about z? Z also we extracted from our curve. This curve is y square plus z square equal to 9. This is the bounded region condition which is given in our question, from which we extracted what is z limit. That is z lies between from 0 to square root of 9 minus y square. Now our function is 2x square y I minus y square j plus 4x z square k dot f dot n. First we are finding, because to substitute in the formula, surface integral of f dot n ds is our formula. For that f dot n is required. First that we are calculating. So f dot n, I dot I exist. So this is exist dot product. So 2x square y into I dot minus I minus 1. So minus 2x square y. Minus 2x square y, we obtained the result in which this value we are going to substitute. When we are substituting here x equal to 0, the totally f dot n is vanished. So we substituted. If it is f dot n is vanished, then totally this phase integral result is 0. So we have seen it. This phase S1 completely we finished it. Phase 1, that is our OAB. The value is 0. Next, immediately we will move to our X2, that is opposite to this S1 phase. So we can see this figure very clearly which phase we are focusing, that is in different color. We put it to understand more. Phase 2, that is CED. CED, that is from the origin. Here X, the dimension, from 0 to 2 it moves. So X equal to 2. It is YZ plane. That is just opposite to our AOB. This is our S1 phase. Just now we have discussed it. And S1 phase opposite phase is S2. Here the normal vector is minus I. Here the normal vector is I. That's the difference. Remaining the plane and all. This is also YZ plane. This is also YZ plane. We have to imagine ourselves a cylinder box which is there on our table. It is in 3 dimensions. So the surface just opposite to the upper face. This is S2. There the normal vector is I. So that's what here it is written, the unit outward normal vector. That is n equal to I. Now the same dy dz is there. So y lies between 0 to 3. Then z lies between 0 to square root of 9 minus y square. That we know our function is 2x square yi minus y square j plus 4xz square k dot I f dot n. So here only I dot I exists, because j dot j, there is no j term, there is no k also, only it is that here there is no k. So only I dot I only exists in this particular our f dot n. I dot I equal to 1. So 2x square y into 1, which is equal to 2x square y. Now x value is 2. We will substitute in the x place 2. So put together, we got it, our phase 2, that is our S2, that is ECD. There the unit normal vector is our n is I. That f dot n we substituted, we got it 2x square y. Now x is taking the value, that is x dimension from origin to 2, which is given in our question. Then substituting here 2 into 4, 8y. The value we got it after doing the integration. That is our phase 2, S2, ECD. Now we will do the integration of our phase 2, that is YZ plane. This we are focusing. This S1 already we got it 0. That's what we didn't do integration. That is f dot n, the value we got it 0. So anyway, f dot n, completely the integration no need to. So just we put the result. Whereas S2, we got it 8y. So we will do the integration. First, we will focus with respect to z, we will focus. So we can see the animated one, which we are going to concentrate. It is circled here. So now 8y, just we push it before the integral. because mainly we are going to focus on our with respect to z. Here also the curved one we gave importance for the interior integration. So we can see it here, this y0 to 3 we didn't touch at all. 8y as it is, this dy as it is. We brought the changes. This dz integral is z lower limit, upper limit, that is from 0 to square root of 9 minus y square. So we are in our phase S2. So this is the last step. We did the integration dz, that is z. Z is going to take the value that is in the place of z, upper limit we substituted. The lower limit is 0. Z place if we substitute it is 0. Now this we are going to do the integration. We are going to play a small trick here. That is, this 8y is there. We split it in such a way to make our integration very comfortable. For that purpose, but mathematically it should obey whatever we are doing to make our integration very easier. Without obeying the mathematical laws, we can't do it. So 8y, we split it in such a way, minus 4 into minus 2y. Why? The reason is, we can see here the formula. This formula we decided to apply to do our integration more comfortable, convenient and easier. That is, this 9 minus y square we have taken as f of r, minus 2y, it's nothing but f dash of r. So f dash of r, this is playing a role. This is playing a role, f of r. N is playing the role, root means 1 by 2. Exactly, it fits to our formula. So, f of r power n plus 1 by n plus 1. Our n is 1 by 2. So, 1 by 2 plus 1 by 1 by 2. So, this is f of r power n plus 1, 3 by 2 divided by 3 by 2. So we can see it, the 3 by 2 only it has become here. So this is the last step what we obtained. Now this put together it has become minus 8 by 3. 9 minus y square power 3 by 2 by 3, 0 to 3. So minus 8 by 3, we are substituting the place of y, 3 we are substituting. So 9 minus 9, the upper limit substitution, we got it, the value is 0. This is limit formula. And y place we substituted the lower limit value 0. Then here we can see it, 9 power 3 by 2, it's nothing but 1 by 2. We can write like this, 9 square root, it's nothing but 3, 3 cube, it's nothing but 27. So this cutting, we got it 9. So minus 8 into minus 9, we obtained 72 is a result of S2. S1 result is 0. S2 is 72. 2 phases we completed. We will move to the phase 3. Phase 3, we have taken O, B, D, E. This phase in a different color we marked it. That is, it is our dxz plane. We can see it, xz plane. That's what here dz, dx it is written. The question will come, why we can't take dx, dz? Already we are giving importance, the curved one, interior limits if we keep, then we will be very comfortable in solving the problem. That is the reason dz, dx. And here, this we are focusing, we can see it. For this, the y, this side is opposite side. So the y value is 0. If it is from here, the unit normal vector is j. But we are focusing this side, this face we are focusing just opposite to that. Then here it is minus j. So we can say it here. The unit normal vector is minus j. So here our z, which lies between 0 to square root of 9 minus y square, and x lies between 0 to 2. Here our f dot n is there. So complete our f is 2x square yi minus y square j plus 4xz square k. The dot product of, here minus j should come. So it is actually to say it's a plus y square. So when y equal to 0, we are substituting here. So f dot n totally it has become 0. This is our S3 phase. So f dot n ds, completely our S3 phase, the value is 0. So far we completed S1, the phase OAB, value is 0. And ECD, the phase S2, the value we obtained 72. And OBDE, the value we obtained 0. 3 phases we completed. We will move to phase 4. Our phase 4 is O, A, C, E. This is our phase. It is in XY plane. That's what here dy dx. So xy, it is playing the surface role. Then another one, our normal vector which is perpendicular to this surface, that is which is in z dimension. The z dimension regarding the normal vector is k. So we can see it here. This is our face and this is our z dimension, but this is opposite to this. That is the reason here we have taken minus k. That is opposite to this side it is there. It has taken minus k. From the figure we can see it very clearly. From origin to the z dimension here. But this face is opposite to that. Yeah, it's perpendicular to it, but it is an opposite side. So minus k. Now our z, so we can see it here. So we can see very clearly. Here the mistake it is there. That is, here we have to write x lies between 0 to 2. Because here we have taken dy dx. So x lies between 0 to 2. Y lies between 0 to 3. Then this is our f and this is our n, that is minus k. So we will do the dot product. So if you do the dot product, these two to be done, the dot product. So 4xz square into minus 1, that is minus 4xz square, where we can see here our z equal to 0. That's what here it is there. So we are substituting the value, z place is 0. Then totally it has become f dot n, the value is 0. So completely our S4 value is 0. So the final one, our phase 5, that is A, B, BC we have taken. Our curve, we have taken our y-x plane. We can say it our y-x plane we have taken, for which we have to find our unit normal vector. Even seeing the figure, this is the focus, the different color which is given in pick which side we are focusing now, for which we have to obtain first unit normal vector. The before and all, it is very easy. From the figure itself, seeing the dimensions, if it is missing, we wrote it, we put the value as 0. If it is an opposite also, we have taken the normal vector. If it is an opposite direction, we have taken negative of that normal vector. The four phases we completed in a very easy manner, whereas here we have to find the unit normal vector, for which here we can say it, our y lies between, we know it, from 0 to 3, which is mentioned here, whereas x lies between 0 to 2, which mentioned here. So this unit normal vector, that is the given vector, whatever it is there, to convert it into normal vector, the formula is the gradient of what is our equation, y square plus z square divided by modulus of gradient y square plus z square. That is gradient. First, actually, the numerator 1 we are calculating. That is the gradient. It's nothing but I dou by dou x plus j dou by dou y plus k dou by dou z of y square plus z square. This we have to do it with respect to, if you are doing here with respect to x, there is no term at all. So this part is vanished. Whereas coming to here, y, yeah, there is a term y square is there. So 2y, 2yj, and z square is there. 2z, that is related to this, 2zk, divided by the upper part 2y square is 4y square, and divided by 4z square. That is, here modulus symbol is there. So square root of the squares we will be writing. That's what it is followed here. So we are focusing the last phase as 5. Now it is a simplified form, that is yj plus zk by square root of y square plus z square, we got it. And the numerator, we placed it as it is, whereas the denominator 1, square root of y square plus z square, that is, this is the surface, that equation which is given in the question, y square plus z square equal to 9. So this y square plus z square equal to 9, we replaced it. Now numerator as it is, that is yj plus zk divided by 3. Now f dot n we will find. Completely our f is, which is given here, dot our n. Just now we found our unit of vector, that is yj plus zk divided by 3. Now we have to do the dot product. So the dot product, we know it, j dot j exists. In that manner, this j dot j. So minus y square into y minus y cube, the down one is 3. 4x z square into z, that is 4x z cube by 3. We can see it. Now the formula, actually what we are going to substitute, for which we needed modulus of n dot k. N already we found, Here it is there. Yj plus zk divided by 3 dot k, because we are in the xy plane. So the unit normal vector in the z dimension, that is, which is perpendicular to our surface of xy plane. So the unit normal vector is k. So it is written here. So this simplification is k dot k only exists. So z by 3, our z by 3, z equal to this, we extracted, that is x square plus, z square plus y square equal to 9, that is given in the question. So from which z square equal to 9 minus y square, z equal to square root of 9 minus y square by 3. So now the fifth phase, S5, it's nothing but our A, B, D, C is, we will evaluate, that is double integral, surface integral, f dot n dx dy divided by n dot k, where our region is projected on our S5, which is in xy plane. This we have taken. Now our S5, this is the result of what we obtained our f dot n, which is placed there, dx by dy by modulus of n dot k, that what we obtained, we put it. So small simplifications we are doing, that is this 3 we are bringing up. So this 3 getting cancelled. The numerator one is minus y cube plus 4xz cube divided by square root of 9 minus y square dx dy. So now this integral we have to focus. How to focus? How to do this integration? Looking at that only, the first integral, 2 parts we can split it. So here we split it and we wrote it in such a way that surface integral over our face S5 minus y cube divided by 9 minus y square into dx dy plus this term 4xz cube divided by square root of 9 minus y square dx dy. So this integral is very complicated one. Any method, substitution method or the previous phases, to substitute we have taken one easy formula we did, no way. It is more, it will become complicated one. This is very easy, simply we can do it. Whereas this complicated one, how to deal? So first, this what we are getting, this is first integral, this is 2 integrals we have to do it. First one we will simplify now. So first integral is minus y cube divided by, so we can see it here, minus y cube divided by square root of 9 minus y square dx dy. That is our first integral of our 2 integrals. The first one we are going to focus. Minus sign we didn't take it. What is the result we are going to get for this? We will add minus sign to that finally. Fine. We will focus this integral now. So this is the integral. So whenever it is a very complicated one, otherwise regarding curves which is in a circle, if it occurs, better to do the integration polar form. If we go quickly, we can solve the integration. So on that basis, we assumed y equal to 3 sine theta. Both the sides we are doing the differentiation, that is dy equal to 3, it is written as it is, sine theta The differentiation is cos theta d theta when y equal to 0. So whatever we are going to do the substitution here, the limits also the changes will be there. So we have to check whether is there any changes in the limits. So when here y equal to 0 is there, that we are going to substitute here. So y is taking the value 0 equal to 3 sine theta. So the 3 also we pushed here. So 0 equal to sine theta. We know it 0, it's nothing but we can equate it. Sine 0 equal to sine theta, theta equal to 0. So here there is no change at all. When y equal to 0, even the angle theta equal to 0. But when y equal to 3, here is there that we are going to take. We are going to substitute in this particular place. So 3 equal to 3 sine theta. So sine theta equal to 1. So sine of pi by 2. We know it here. That is the value we have taken. So theta equal to pi by 2. So this part only we are going to focus. So y equal to 0, that we wrote it theta equal to 0. That we discussed just now how we obtained it. When y equal to 3 and we obtained theta equal to pi by 2. And y we have taken 3 sine theta. We assumed it. The polar one we have taken to do the integration very easy manner. So 3 sine theta for y. Here y cube is playing the role. So 27 sine cube theta divided by square root of 9 minus is as it is. Y plays 3 sine theta. So 9 sine square theta. Here dy it's nothing but 3 cos theta d theta. And this dx we are focusing on only this. The dx actually as it is coming with us. Only we didn't. First we are focusing this. What is the result we are going to get? That we will substitute. Finally we will do the outermost integration. So now 0 to pi by 2. Here the simplifications 1. Here if you are noticing 9 from the square root we are taking, it is becoming 3 square root of 1 minus sine square theta. So 3 into square root of 1 minus sine square theta. That we know the identity. Cos square theta plus sine square theta equal to 1. So we can write cos square theta equal to 1 minus sine square theta. Cos theta equal to square root of 1 minus sine square theta. So this is becoming 3 cos theta. So this completely it is becoming 3 cos theta. This getting cancelled. That's what here the cancellation is occurring. So the leftover is, this is also cancelled. So only we got it 27 sine cube theta d theta. This always the sign the trigonometric one, if they have power, then related to trigonometric formulas we have to substitute. So the trigonometric formula is sine 3a, that is 3 sine a plus 4 sine cube a. Now from which easily we can get it sine 3a minus 3 sine a 1 by 4. It's nothing but sine cube a. Ours is in terms of theta. That's what it is written here. Whenever the trigonometric one, if they have power in the integration, the relevant easy formulas to be substituted, then we can do the solutions very easy way. So 1 by 4 of sine 3 theta minus 3 sine theta. So this 27, the 4 we have brought it out. 27 by 4. Then sine 3 theta, the integration is sine of some term, that is in terms of theta it is there. Sine, the integral is minus cos of some term, that is 3 theta, divided by its coefficient. The coefficient of theta is 3. So divided by, which is written here, sine theta, the integration is minus cos, already minus 3 is there, put together plus 3 cos theta from 0 to pi by 2. Now, this 27 by 4 as it is, here the theta place, we are substituting 90 degree, that is cos of 270. We can write cos of 180 plus 90, it's nothing but cos 90, and here also cos 90. The upper limit totally vanished, limit formula, and the lower limit, the value is 0. Here we are substituting cos 0 is 1, so minus 1 by 3. Here also cos 0 is 1 plus 3. So we obtained 27 by 4 into 8 by 3 equal to 18. Now that we substitute for our outermost one, outermost integration is 0 to 2, 18x dx. Very simple integration, that is x is having the power 1. So now this is the one we focused it. This we did in a very simple manner, taking polar form. This value we got it 18, that's what this is. That we substituting here. We can see it here very well. So we can 18 x square by 2 equal to this getting cancelled, 9x square from 0 to 2. So x place we are putting 2, so 9 4s are 36. So the two integrals are there. First one we evaluated, we got the result 36. We are in phase 5. So this we completed. We got it 36, minus we didn't take it, so minus 36 we got it. This we are going to focus now. That is a second integral. Here we can see it, 4xz cube divided by square root of 9 minus y square dx dy. So we can see it very well. This z cube, it is there. The z cube, we can write it as z square into z we can write. So z square, it's nothing but the what is the surface regarding the equation which is given in our question, that is region bounded by y square plus z square equal to 9, from which we extracted 9 minus y square. So z square equal to 9 minus y square, z is square root of 9 minus y square divided by square root of 9 minus y square dx dy. So this both, it's getting cancelled. So 4x of 9 minus y square dx dy. So the interior one, y from 0 to 3, the outermost one, 0 to 2. So the 4x of 9 minus y square dy dx, because we defined the interior one for y with respect to y, we have to do it. So what we are going to focus, that animated one is mentioned here. So we can see it, the animated one. So now this is 36x with respect to y we are doing. So 36xy which is written, and this minus is as it is. The 4x we are taking inside, here 4x, and y square is there. y square, the integrated one, y cube by 3, and 0 to 3. This outermost we didn't touch at all. So actually here dx should be there because outermost is dx. Now only we completed this is with respect to y. Now in the place of y we have to substitute our upper limit value 3. Here we are substituting 3, 36, 3, 108. This x is as it is. This minus is as it is. Here this y place y cube 27. That is 27 by 3, 9. 9 fours are 36. This x is as it is. So we obtained 72x. Again, the final outermost one, we have to do the integration. So 72x, x power is 1. So x dx, the integral is x square by 2. 72 by 2, it is 36 x square from 0 to 2. X is taking the upper limit value 2. So 36 into 4, 144. The phase 5, actually this is the integration, we got it. Without minus, we did the integration, we got it 36. Finally we applied this, then it has become minus 36. This just now we discussed, we got it 144. So the result is 108. So we can see we will come to the final conclusion of this topic, Gauss Divergence Theorem. That is, we have taken the function 2x square y I minus y square j plus 4x z square k, for which the Gauss divergence formula is volume integral of divergence of a given vector function dv, which is nothing but surface integral of dot product of vector function into dot product of unit normal vector in the dimension, that is which plane it exists, that area to be found. Now according to ours is what is the condition which is given, for which here the condition which is given in our question, that is this curve, it is given y square plus z square equal to 9, and here this x direction which is given x equal to 2, and it lies in first octant. That is the values, if it comes negative, that we will neglect it because there is a word first octant it is there. So we have taken only the positive values. And here this is also from origin to y dimension is 3. So y dimension from 0 to 3, x dimension is from 0 to 2, whereas z is from 0 to, this is the curve square root of 9 minus y square. So what is the given question condition? Using that, the cylinder geometrical figure we have drawn it, and the left side we calculated, we got the result 108, and we moved to our phase 1, that is AOB. It lies in our ZY plane, and for which the opposite to the face is S2. Here S2, that is normal vector is I in x dimension, whereas here it is minus I because S1 is opposite to S2. Now S1 calculating the value what we obtained is 0. Next we moved to S2. Here S2, here the unit normal vector is I, because normal vector which is perpendicular to our surface. We should not forget we are doing this problem in 3 dimension. So the normal vector which is perpendicular to our surface, the face is S2. We calculated, we got it 72. Next we moved to our phase 3. Here this is our phase 3. and phase 4. This is our phase 4, and here this complete one is our phase 5. Phase 3 also, the result we have taken, it lies in here z exoplane. Here the unit normal vector is minus j. Seeing the figure, we can easily, it is opposite to our perpendicular vector. So j opposite, so minus j. So now the next S4, here we have taken XY, the plane, that is OACE. This phase we calculated. Here minus k is our unit normal vector. Just this is opposite to our this dimension. If it is opposite to that dimension, negative of normal vector will play a role. And finally, S5 we calculated ABDC. So completely we discussed in detail about this cylinder problem, and we found that is Gauss Divergence Theorem, that is volume integral of divergent F dv, which is equal to surface integral F dot n ds. Both are equal. We verified Gauss Divergence Theorem. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.